We have a class on December 9. I think from 9 to 11, right? This will be the same class as we have today, TR. Okay, last time we have something about this part, which we still need to answer, but I will skip for a while and go for, we call the next part is trigonometric integrals. Okay. But this is actually integrations using trigonometric identity. Okay. So I will just take some example here. Okay. So whenever we have a what is that? What is that? Okay, it's okay. So whenever we have any sine, cosine, and they have power. For example, this having sine with power of 5 and cosine is power of 2. We could always rely on the basic identity which we have before. Okay. Sine squared plus cosine squared equal 1. So by doing this, we could rewrite the integrations and write that this will be sine squared x squared cosine squared x, and then the leftover we have another sign here, right? Okay. Now we have a complete with the same original integration. So sine squared squared, and then sine, which we are going to have sine with power of 5, and then cosine squared still cosine squared. So what we are going to change the structure. Okay. So we expect to change one of them and then make a substitution, which when we derive, the sine and cosine can be cancelled, right? So by doing this and then continue, we can write this as 1 minus cosine squared, all right? And the rest is still the same. And we can write and take u as cosine x. When we're doing this, we can take the sign. Okay? We can take the sign to be cancelled, right? So basically, this is similar to what we have in substitutions, but this is more specific to the trigonometric. Okay? So we are going to have, this will be, I will write negative in the front. Well, it's actually 1 minus u squared and u squared, and the sign will be cancelled, and it will be the leftover is the sign, the minus signs, okay, on the front. Okay, so this will be u. Okay. So I exchange the dx is 1 over sine x negative, so this will be cancelled, and I will write the negative in the front here. Okay, and we can easily solve this, right? Okay. How to solve? Just expand and then multiply and then integrate each one by one. Okay.
Is that 1 minus u squared?
Oh yeah. Good. It means you are ready for the quiz.
No.
Okay, so this will be negative 1 minus 2u squared plus u4 and multiply with u squared, right? So we will have u squared minus 2u4 plus u6. Okay, one by one we can integrate. So this will be, and I will integrate and then substitute u back to the cosine x. Okay, so this will be negative 1 over 3 cosine with power of 3 and this will be minus will be plus 2 over 5, and cosine 5, okay, and then this will be negative 1 over 7, cosine with power of 7, x plus c. Okay. So, if you have the textbook or you have the digital files on the textbook, it has like some case, like you have sine with the even power, odd power. I don't think you need to memorize all of that. So, with the basic identity, you can just try to find out which one that when you substitute, it will be like much easier to simplify the equation. I think just follows that rules. Every time you see this like sine and cosine, they have powers. You can exchange, like maybe sometimes you need to substitute the cosine, sometimes you need to substitute the sine. Okay. Okay. I hope that will be clear. Okay. So of course, like how to know which one? You need to try. You need to try and then experience on the first hand. Okay. So the first hand experience, learning, it will be better for you. Okay. Rather than read the books and you see the case 1, you have sine, even, and then cosine, odd, blah 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 blah. Not good. I also don't like it. I prefer first-hand experience, and you know how to follow that rules. And then you know, oh, I need to change this. Oh, this will be cancelled. This. And actually, you can identify easily when you try it by yourself. Okay. So the first thing is sine and cosine. The second thing is the tangent and the secant. So from here, sometimes we forget. Okay. But if we multiply with 1 over cosine squared, okay, so let's multiply all with 1 over cosine squared. This will be tangent squared plus 1 plus or equal secant squared. Okay, and this is the second identity that we can get easily from the first one. Okay, so no need for like a whole memorization, right? Okay. Okay, so tangent squared plus 1 secant squared. So another possibility for the questions is if you have a combination of tangent and secant. Previous in this one we have sine and cosine, and the other one will be tangent and secant. Okay. Now, for example, if we have, let me check. If we have this, and I will give you 2 kinds of integrations. The other one will be this. So what should we do? So we expect this to be solved by taking substitutions and also using the identity on the trigonometric, right? But how do we make sure that we are doing right? Of course, we need a basic derivative. So you need to know derivative of tangent and derivative of secant. Because if we want to substitute, we would like to derive, right? We would like to derive to find the dx. Okay. So whenever we have the conditions, so notes, let me write notes first, that the ddx of secant, this will be secant x, tangent x, and ddx of tangent is secant squared x. So based on these two, then we could arrange our integrations that which one that is perfectly makes sense, that we can, okay, maybe we would like to substitute the secant. So maybe, for example, here, maybe secant 6 and then secant x. Can we do that? And then we try this part also. Can we do that? And that's how we could find. So my idea here is first, if we have this one here, now it has like 5 and 7. So if we take this like 4 and this will be 6, so I will separate another, become secant x, tangent x, dx. Now when we do this, we expect the secant x and tangent x to be cancelled. That's why the idea is to take the secant as our substitution. Okay, so this part here, all will be in terms of secant. Okay, so secant, I will change the secant here. So this secant tangent with power of 4 becomes secant square x minus 1 and then squared. Okay, so it is from tangent squared squared. The tangent squared is secant squared minus 1 from our identity. Okay, we come here, and then this is still the secant. So everything will in the terms of secant. So this will be secant. This will be still secant x tangent x dx. And then, oh, I forgot this is still having integral. U is secant x. So du will be secant x tangent x dx, which we expect to cancel the secant x tangent x that we provide in the equations. So we can exchange everything. This will be u 6, and then all is cancelled, so this is just du, right? And then similarly, from what we have before, we can expand and then multiply. And then this will be u10 minus 2 u8 plus u6. So this will be, I will integrate and then substitute to the secant x. So this will be 1 over 11 secant with power of 11x minus 2 over 9 secant with power of 9x plus 1 over 7 secant with power of 7x plus a constant. Okay, so that's the one example. Another example is to separate the tangents. Okay, so this is separation the secant and tangent, and the other one we are going to separate the tangent or the secant squared. Okay. So first is we take the secant x for the secant x tangent x, and the second one we expect to separate the secant squared that we are going to capture from the tangent. Okay. So here, let me go through. Okay, so this one we can take as secant squared x, secant squared x. So we separate the secant squared becomes 2, and then the secant squared itself will be, we can write as a 1 plus tangent squared x. Okay. So we multiply with this, and still we have the secant squared x. Okay. So the last one here, we expect this to be here because we want to cancel when we substitute the tangent. So this will be tangent 6x plus tangent 8x. This is secant squared x dx. So this one will be tangent x, and we are going to cancel the secant squared x from the u equal tangent. So we are going to have u with power of 6 plus u with power of 8, and this will be du. Okay. And then you can have 1 over 7 tangent plus 1 over 9 plus c. Okay. So for tangent and secant, two possible way for you to try is to separate the secant tangent and separate the secant square. Okay. And of course, how do we know which part? Of course, you can see and you can identify through the formulations. Like this is like without power, or power, this is an even power. You can see from that. But I think you can just try and experience it by first hand. It's really more, I think, the learning experience will be more. Okay. Another example that will be, I think, helpful, especially in calculus 2 or in engineer of math, or maybe in mathematics course in general, is to have the let me give you like a quick example, and then we can have a short break and we can have a quiz. Okay. So if we have the integration of sine squared x dx, okay, how do we solve this? This will be a typical like daily problem in the future courses. How do we solve like trigonometric but having with a square? Usually sine or cosine. Yeah, sine or cosine, but with a square. How do we integrate this? Which one? Yeah. Yes, I think that's the best approach. So this double angle formula will be very useful. So this is the original formula. You can rewrite this as or if it is in the cos squared, we can write in terms of this. Okay. So basically, this can be changed into half 1 minus cosine 2x dx. And then we can integrate each one by 1, x minus sine 2x over 2 plus c. Or if you want, we can write this is over 4 plus c. And how about if we have like sine with power of 4? Then we could understand this problem by taking the sine squared and then squared. Okay. This can be understood by taking the sine squared and then squared dx, which means that we are going to substitute using the same double angle formula that we have half 1 minus cosine 2x, and this will be squared dx. And then you are expected to have another square, which you can using double angle again. So we will see, right? Maybe sometimes you need to use 1, 2 times, 3 times double angle.
What's your the question about the 1 minus cos 2x? Like also in the integral there's
Yeah, from here. So this will be 2 sine squared x. Okay, so sine squared x is, okay. Okay. So this double angle will not be like only useful for our course, but in the next course, this will be really helpful. Okay. Because sometimes you will see more equation in terms of trigonometric a lot, especially using this squared form in the squared form. And sometimes if you follow this, following the courses, you will see like there will be many things like this that requires your understanding in this integration. Because in that course, it's not expected that the teacher will review all this. Okay. Okay, I think we are going to have 5-minute break. Is that enough? And then we are going to have a quiz. Is that okay? It's up to you. I'm okay. But your time will be less, right? Right?